We are now going to start building our data access layer for the reports table. We've got this table here that has a user ID, a ID for the report itself, a report type, which we probably won't make a lot of use of in this video, but I want to have some variability to how reports can be generated. A output file path, the download URL where the client will actually retrieve the report out of the S3 bucket, an expiration time for the download URL, which will actually, the reason why we have an expiration is because this is going to be a pre-signed URL. And we have an error message, which will be only populated if we have a failure status for this report. Of course, we're going to have a created at timestamp created automatically for us. We're going to have a started at, which is when the SQS worker has actually picked up the report for processing. And then we have this failed at message in case the report fails for some reason, and we will also populate the error message. And completed at will be populated on success. So some of these fields will only be populated if there's a successful state. Otherwise, it will be in a failure state. So let's go ahead and go to our store package. We're going to create a new file for reports. Once again, we're going to create a report store. And we're going to hold a reference to a SQLX database. In our constructor, we'll accept a standard library SQL database and convert it to a SQLX DB, as we did previously. So we've got new report store. This is good enough to get started. We provide the standard library database and the driver that we want to use. Once again, we have to do our import for libpq. The next thing that we need to do is map our table schema to a Go struct. So let's create a new report type. We'll have a user ID, an ID, which is the report ID. And of course, we are mapping these to the column name of the database table using this DB tag, which SQLX recognizes and will handle for us. I think we had report type, which is a string. We won't always have the download URL or the download URL expiration. So these are going to be pointers because they are going to be nullable in the database table itself. So if we are in a failed state, these will not be populated at all. And in that case, I'm fine with these being null. The started at timestamp will also be a pointer because whenever this record is first created, the started at timestamp will not be populated. So I'm going to keep that value null as well. Completed at is also going to be nil, and failed at is also going to be nil. And what we can do is, based on whether these values are populated or not, we can determine a status to display to the user, whether it's in a started state, requested state, completed state, or failed state. Okay, so this looks good. Let me just double check and make sure all these are populated, or all of these are mapped rather. So now let's go ahead and implement our create method. Accept a context, and we will accept a user ID and a report type. Just like last time, we're using get context. We provide the context here, the address of the struct, which we are populating using the returned columns, and of course, the insert statement and any arguments that are needed. Next, I want to have a method that does the update operation for a given report. We're going to need to update the status while we're processing it. In this case, we will pass in the entire report itself. Fields that will be updatable are output file path, basically everything from here down with the exception of the created at timestamp. So output file path, download URL, Okay, we are updating all of these fields where the user ID and ID are these values. We need to provide values though, so what we're doing here is kind of interesting. We are using this update statement, but what we're doing is repopulating the same struct that we're passing in. So whatever the existing report object is, I'm actually populating the values back into that report struct. And I'm still using the values from this report object as the inputs arguments to this SQL query. This should work just fine. All it's doing is updating the struct itself, but it's obviously reduced a significant portion of the boilerplate that I would have to do using the standard library. One more thing we need to actually do here before we can start writing some unit tests, just to make sure that everything is working correctly, is we need to retrieve it by the primary key. We need to be able to retrieve a report record using the user ID and ID of the report. Selecting all columns from reports where the user ID is equal to this argument and the ID is equal to the second argument, returning all columns, of course. And we're going to establish a report variable so that we can populate that variable with the result set of this query. This looks good. My autocomplete is doing its job, so this looks pretty good to me. I think we are in a good spot to start writing some tests just so we can verify that all these things are working together correctly. Of course, we're going to use our handy dandy test environment fixture. We'll use that to set up our database. And then we will make sure that we're cleaning up our database after the test. So we'll do t cleanup. We'll need to create an instance of our report store. And it takes a database object. Before we start running these tests, you may remember from some previous tests that we ran into some issues when we have a composite key like this, and one of the columns is a foreign key reference to the users table. This means that we need to create a user object so that we have a reference in that table before we start creating records in this table, which makes sense. So what we're going to have to do first is set up a user for this test. First, let's create the user store. Now let's create a user. Let's do a context. Require no error, of course. Now that we've got this user object created, we can start creating report records. So let's say report error is equal to report store create. We'll pass in a user ID and a report type. In this case, the report type is any string. For the API that we're going to be using, it should be something like monsters though. So that should be fine. Let's require no error. And let's require that user equal, let's say equal, the user IDs are equal. Let's require that the report type is monsters. This seems like a good starting point. I just got an error like this. Failed to insert report for user, scan on column index 3 output file path converting null to string is unsupported. So let's go take a look at that. Output file path. That's right. Output file path should be nil, just like these, or it should be a pointer. All right, I'm getting some errors about some bytes not matching up. Let me just make sure that, this said assert that the user ID is equal to the report ID. This is incorrect. This is a case of where I'm too trusting, or I'm being too trusting of my IntelliSense. So this should be report.userid. Okay, let's try that again. Bada bing. This is a passing test. This looks good. Now we want to verify that we can update the report. So let's go ahead and do that. And what I'm going to actually do is populate all of the nillable columns just so that I can make assertions about them, even though that's not how we're actually going to be using this report object. A good assertion to make is that if I change the report type shouldn't change because I'm not making that an updatable column. So let's call this food. And when I update the report in the database, this should be populated with the actual value that's in the database, which is monsters. So I'm just doing this just to verify that I'm not updating the report type. So for these timestamps, I'll just populate each of them and make them like 1 second apart or something like that. I should actually add one more assertion up here, and it's that the created at timestamp was populated correctly. So what I'm going to do is do now is equal to time.now, and I'll just make sure that the now timestamp Unix nanoseconds is less than the report created at Unix nanoseconds. So let's check that real quick. That looks good. We're updating our report type food. The address here, and it's going to be started at is equal to created at plus 1 second. So I've got to create these variables up here just so I can pass the address of them. So that's why I'm doing it this way. All right, this looks good. Even though we're going to be updating the same report object, I'm just going to reference a new variable here. So as is, I'm expecting this to fail because we have this one value here that should not be updated. This should not change at all when we update, when we call the update method, because we are not intending for this to be an updatable field. So let's make sure that this fails. This is failing for a different reason. Let's just make sure we got this. All right, I am getting an error like this. Failed to update report for user scannable destination type pointer with greater than 1 columns, 11 in result. Okay. That error was odd, but this was actually a result of us using the same report object and trying to populate it again. So I thought I was being clever by using the same struct there. You can't do that. We use a new type and we populate the new object and return it. So keep that in mind. Okay, so now that we got that error worked out, I went ahead and added assertions for each of the fields that we want to be equal. So For this first report, I'm making assertions that it's equal to the values of the report that's returned after the update. And there's one exception here, which is the report type. I'm asserting that that's still equal to monsters because we do not expect this to actually be updated when we do a report update. So I'm going to go ahead and run this, and that's passing successfully. There's one more test we need to do, and that's retrieving a report by its primary key. So I'll just call this report 3. And we'll do report store by primary key. And we will say report.userid, report.id. And I'm going to do all of these same assertions, basically. I'm just going to replace all of these with report 3. All right, so we've retrieved the report by primary key. We're storing that in report 3. We're asserting that there's no error after retrieving the report by primary key, and we're making the same assertions, just making these say report 3, and we're making this say report 3 at the bottom here. So we're expecting all those to be equal, and we've got an error. So let's take a look at it. It says there's a syntax error near returning. Silly me. You do not use returning star with a select. That does not need to be there. We can just delete that and rerun this. All right, this is all passing, so I feel confident that all of these helpers are in good shape and will work as I want them to. I think we are now in a good spot to start looking at our report builder, and I think we're also in good shape to start taking a look at creating our API client that will retrieve data from the Legend of Zelda API. I'm probably just going to lift and shift some code from a previous video I did just to make this go a little bit more quickly. But other than that, I think we're in good shape to start working on the report builder.